everyone, today we're going to be writing equations of parabolas. Before we get there, there's a couple things I want to review how to do. The first warm-up is finding the product. When you're given two binomials that are multiplied together, you want to use the distributive property to expand that expression. A lot of teachers have probably used FOIL with you in the past to help you remember how to use the distributive property with binomials. We're going to multiply both the firsts, both the outers, then multiply both the inner expressions together, and then both the last expressions together. Okay, so using FOIL, let's go ahead and get started. First times first here is going to end up being 6x squared. I know that because when you multiply 2x times 3x, you actually take these exponents and add them together. Outer times outer is minus 14x. Inner times inner is minus 15x. And last times last, when you multiply two negative quantities together, that's going to end up being positive. So we would get positive 35. Okay. Let's combine these like terms together. I know that they're like terms because they're both x to the first expressions. So I'll end up with 6x squared minus 29x plus 35 as my expanded expression. Okay. Moving on to the next one, we have x plus 3 quantity squared. I often see this mistake. Let me just show you. Students will square each part and say that this is equal to x squared plus 9. That is not correct. What squaring a quantity means is it means to multiply the expression by itself. So squaring x plus 3 means to take x plus 3 and multiply it by itself. You cannot just square individual parts. I think what the misconception is if there was a multiplication sign there, then you would be able to square each part individually. It would be accurate to say that this was equivalent to x squared times 9. But when you see that plus or minus sign in between, just know that you need to write it out twice and FOIL it in order to get the product. First times first is x squared. Outer times outer is 3x. Inner times inner is 3x. And last times last would be 9. Again, combining the like terms in the middle, we get x squared plus 6x plus 9 as our product. Okay, same thing over here. Again, I see a binomial squared, so I know to write that out twice, and we're going to use FOIL to help us find the product. Okay, distributing, we get 3x times 3x, which is 9x squared. Outer times outer becomes negative 24x. Inner times inner is negative 24x. And last times last would be plus 64. Adding those like terms together, in the middle, we get 9x squared minus 48x plus 64 as our final answer there. All right, the other warm-up that I want to go through is just a review of function notation. So it gives us this function x squared plus 1, and it wants us to find f of x minus 5 first. Do you see how this function says f of x and this function says f of x minus 5? What that means, what that's telling you to do, is everywhere you see an x in this original function, you're going to plug in x minus 5. So this is how it would be written. Instead of x, we're going to replace x with x minus 5. Notice the squared stays the same, and I'm going to keep the plus 1 the same. Now for the purposes of writing equations today, I would want to leave my answer like this in Vertex Form because I can clearly see the right 5 up 1 translations. If you wanted to write it in what's called standard form, you could write the x minus 5 out twice, completely FOIL, and combine like terms. All right, but today we're not going to worry about doing that. If you're already given an expression in Vertex Form where you can see the transformations and identify the vertex, you're going to want to leave it that way. Okay. f of 2x means to plug in 2x everywhere you see x. So it would look something like this. 2x squared plus 1. This one I probably would simplify just because it's easy to quickly square the 2 and quickly square the x. Okay, because there is multiplication here, you can square each individual part. So that would end up being equal to 4x squared plus 1. Again, squaring something means to multiply it by itself. So if you think, what is 2x times 2x? That would be equal to 4x squared. Okay. Over here, negative f of x, it's got the negative out front. We're going to leave the negative out front and just plug in what f of x is equal to. Remember, f of x is equal to x squared plus 1. So I'm going to plug in x squared plus 1. We distribute the negative through, and we would get negative x squared minus 1 there. Okay. And that is going to be it for our warm-up. Now we're getting into writing equations of transformations. Just a quick review here. Function notation for reflections. If I see a vertical reflection, the negative sign is outside of my parentheses. If I see a horizontal reflection, the negative is inside the parentheses. If I see a vertical stretch or shrink, the A is outside the parentheses. If I see a horizontal stretch or shrink, the value is inside the parentheses. If I see a vertical translation, this plus or minus K is outside of parentheses. If I see a horizontal translation, we'll see x plus h or x minus h inside parentheses. So hopefully you see a trend that anytime we're doing something vertical, it's outside parentheses, and anytime we're doing something horizontal, it's inside parentheses. Okay, with horizontal, this function notation right here, where you see f of negative x or f of bx or f of x plus h or minus h, what you're going to be doing there is you're going to be replacing x with whatever is inside the parentheses. Okay, so that's like what we did in that warm-up, these first two questions here where we were plugging in something different for x. That's what you'll have to do when you see horizontal transformations. Please note also that for horizontal stretch or shrink, don't forget you have to use the reciprocal of the given scale factor. All right, in example 1, it says, let the graph of g be a vertical stretch by a factor of 2, followed by a translation 3 units down, followed by a reflection in the x-axis of the graph of x squared. Write a rule for g and identify the vertex. So my first transformation is a vertical stretch by a factor of 2. And it's really important that you do it in the correct order. You have to do the transformations in the order that the sentence gives them to you. My second transformation is a translation 3 units down. And my third transformation is the reflection in the x-axis. Okay, so we're going to start with number 1. Vertical stretch by a factor of 2. Because it's vertical, the 2 is going to go on the outside of parentheses. Okay, so I'll put a 2 on the outside of parentheses, and I'm starting with the function x squared. So I end up simplifying that and getting 2x squared. Then I'm going to do my step number 2. Step number 2 is a translation 3 units down. Again, down is vertical translation, so I'm going to put the minus 3 outside the parentheses. So I'll have the minus 3 outside parentheses. So I get 2x squared minus 3. Okay, and then my last transformation is a reflection in the x-axis. That's another way of saying a vertical reflection. So we want to put the minus sign outside of parentheses. Okay, so for step number 3, we're going to put a minus sign outside parentheses, and I just copy down what I got in step 2 inside those parentheses. Distributing the negative sign through, we get negative 2x squared and then plus 3. All right, so there we go. We're going to name this function g, since it says to write a rule for g. We got negative 2x squared plus 3. And the vertex is the other thing we have to identify. Notice that there has been no shift left or right, but there is a shift up 3. So left or right would be 0, and then up 3. If that's unclear, just keep in mind another way that you could write this expression g of x is you could write it as negative 2 x plus 0 squared plus 3. Really, that makes it easier to see that there's been no shift left or right, but there is a shift up down. Okay, we just don't typically write plus 0 in an expression. You would want to simplify it. Okay, so I'm going to circle g of x, and I'm going to circle the vertex. All right, quadratic forms, there's really 2 types of quadratic forms. My favorite is vertex form because it's very easy to identify the vertex. You can clearly see the left, right, and up, down shift so that you can identify the vertex very easily. The other form is called standard form, which we have not seen before. We're going to talk more about standard form in lesson 5. Okay, but just for now, with vertex form, if you take a look over there, B, if that is 1, another way a lot of textbooks write vertex form is just like this. Okay, and really that all they're doing in order to get that form is making the B value equal to 1. In vertex form, the vertex can be written as h comma k, again because h represents that left-right shift, and then k is that up-down shift, which will determine the vertex. xy is just any point on the curve or on the parabola. Okay, for standard form, I don't like this form as much because you really can't see the transformations very well. The a value out front, it still indicates the vertical stretch or shrink, and if there's a negative out front, it would still indicate a vertical reflection. However, it's very difficult to identify the vertex using standard form because it's not easy to see how the vertex has been shifted left or right, and really there's no k value anymore either. It says the b value in standard form has a different meaning than the b value in vertex form. Notice there is no h in standard form. It is difficult to understand the left-right shift when given standard form. We're going to talk more about how to find the x-coordinate of the vertex for a standard form quadratic function in the next lesson. The c value in standard form indicates the y-intercept. Notice that there's no k value. So the c value and the k value are 2 different things. The c value here represents the y-intercept of the function. It does not represent the y value of the vertex. Okay, again, the c value does not represent the y value of the vertex. We're going to talk more about how to find the y-coordinate of the vertex for a standard form quadratic function in lesson 5. Okay, so right now the vertex is a big old question mark for standard form until we do the next lesson. xy, again, is any point on the parabola or on the curve. In example 2, it says, let the graph of g be a translation 3 units right and 2 units up, followed by a reflection in the y-axis of the graph x squared minus 5x. Write a rule for g. Note, because f of x is given in standard form, you'll not be able to easily identify the vertex of g of x. We have to keep that in mind. See how this is given in standard form? X squared minus 5x plus 0. There's really no way to see that left-right shift of the vertex or how the vertex has been shifted up or down. Remember, the c value represents the y-intercept. So in this case, we're not going to be able to easily identify the vertex. But that's okay. Let's still do the transformations. The first transformation here, I'm going to label it in blue. Make sure you do it in the order the sentence gives it to you. We have 3 right. The next transformation I see is 2 up. And then it says followed by a reflection in the y-axis. Right, reflection in the y-axis. That's number 3. Okay, so let's do each one of these step by step, making sure I simplify after each transformation. 3 units right. The function notation for this is f of x minus 3. What that function notation means is that we're going to replace x with x minus 3. Okay, so we're going to plug in x minus 3 everywhere we see x. Right, remember, we're starting with this x squared minus 5x. So instead of x squared, we're going to write x minus 3 squared. Then we have minus 5. Again, I see another x, so I'm replacing that with x minus 3. Because it's already in standard form, let's go ahead and simplify. X minus 3 squared, we're going to want to FOIL that out. So let's write it twice. And then I'm going to distribute the negative 5 through to each term. So we'll have negative 5x plus 15. FOILing, first times first is x squared. Outer times outer is minus 3x. Inner times inner is minus 3x. And last times last is plus 9. And then I still have the minus 5x plus 15 here. Let's combine like terms. We have minus 3x and minus 3x, which gives us minus 6x. And we have another minus 5x, so that's going to be minus 11x. And then plus 9 and plus 15, that's going to end up giving us plus 24. Okay, so that's number 1. Number 2, it says 2 units up. I love vertical translations because you just tack on that plus 2 to the very end. Okay, so for number 2, we're going to have x squared minus 11x plus 24, and I just bloop, put a plus 2 on the end, and I get x squared minus 11x plus 26. Okay, and then number 3 is a reflection in the y-axis, also known as a horizontal reflection, so I know that I'm going to put that negative inside parentheses since it's horizontal. So I'm going to be doing f of negative x. Again, this means to replace x with negative x. So anytime you have horizontal transformation, you're plugging in something. So for number 3, instead of x, I'm going to see negative x squared minus 11 times, again, plug in negative x, plus 26. Okay, whatever you're plugging in, put it in parentheses. Simplify negative x squared. If I multiply that by itself, negative x times negative x would be a positive x squared. Then we have plus 11x and plus 26 once we simplify. All right, and we are looking for a rule for g, right? Write a rule for g. So g of x is going to be equal to x squared plus 11x plus 26. Notice that it's very difficult to know what transformations are going on left, right, or up, down when the function is written this way. This is not vertex form. Not vertex form. It's called standard form, and with standard form we can't determine the vertex at this time. Again, we have to wait till the next lesson to be able to identify the vertex. In example 3, it says the graph is a translation down 1 followed by a vertical reflection in the x-axis of the graph x minus 2 squared plus 4. Okay, let's read the transformations in the correct order. We have a translation down 1 first, and then we have a vertical reflection in the x-axis. We want to make sure we do it in that order. Please note that the original function given to us is already in vertex form, so I want to try to keep it in vertex form. That way I know what the vertex is. All right, so translation down 1. These are my favorite. We just put minus 1 outside the parentheses because it is a vertical translation. You just tack that minus 1 right onto the back. So for number 1 here, let's see, we would have our function x minus 2 squared plus 4, and I'm just going to plop that minus 1 out back. Simplifying, we get x minus 2 squared plus 3, right? 4 minus 1 is plus 3. The second transformation that we see is the vertical reflection in the x-axis. Again, that word is vertical, so I know the negative goes outside of parentheses. So for number 2, we're going to put the negative outside parentheses and then copy down what we got in step 1. X minus 2 squared plus 3. Okay. I am going to distribute that negative through to both of these terms. Now this can be kind of tricky. I want you to remember in the last section, here's a little thought bubble, in the last section when we worked with absolute value functions, like let me just give you a separate example. When we worked with absolute value functions, that negative never went inside the absolute value when we distributed. Remember we had this leading coefficient 1 here. So we would just distribute the negative to that leading coefficient of 1, but the inside the absolute value never changed. That's the same thing here. We're never going to go inside these parentheses and change the x minus 2. You want to pretend like there's a little leading coefficient of 1 out front here, and that is what is going to be multiplied by the negative. Okay. So we want to call this graph the graph of g. So g of x would equal negative x minus 2 squared minus 3. Okay, and I'm going to just leave it like that because it makes it easy to identify the vertex. We can see right 2 down 3. So because we see the right 2 down 3, the vertex is going to be 2, negative 3. I've had some students in the past years that would want to continue this, and they would write out the x minus 2 twice and completely FOIL it out, but we don't want standard form. If you completely FOIL that out, you're going to end up getting standard form, and that makes it very challenging to identify the vertex. Okay, so let's leave it just like that. Student practice, let the graph of g be a vertical shrink by a factor of 1/2. Followed by a translation 2 units up of the graph x squared. Write a rule for g and identify the vertex. Alright, so we're starting with x squared, and my first transformation is a vertical shrink by 1/2. Okay, because it's vertical, the 1/2 goes outside the parentheses. So I'd have, for number 1, I would have the 1/2 go outside the parentheses. And I'm going to copy my function x squared down, so I get 1/2 x squared. Okay. My second transformation is a translation 2 units up. These are my favorite. It's a vertical translation, so it's outside parentheses, and we just tack that plus 2 onto the back. Okay, so for my second transformation, we're going to have the 1/2 x squared, and we just tack on bloop, plus 2 right on the back to get it to go up. So we get 1/2 x squared plus 2. All right, and it's asking us to write a rule g. So I'm going to say g of x is equal to 1/2 x squared plus 2. Now, what is the vertex is the next part of the question. Well, there's really no left-right shift that I can see. If you want to rewrite this as x plus 0 squared plus 2, that makes it a little easier to see that there's no left-right shift. This isn't necessary. Normally we don't write plus 0 in a simplified answer, but you can see how it works in the vertex form. Okay, so we have no left-right shift, and then you can see that we have an up 2 shift. So the vertex is going to be no left-right shift, and then up 2 shift, 0, 2. Right. This function actually could also be written in standard form. Like this is vertex form. If I want to write it in standard form, we could write it like 1/2 x squared plus 0x plus 2. You can see if I simplified standard form, I would get my function g of x written like this. The only reason why I don't spend time writing in standard form is, again, because right now standard form is not going to help us identify the vertex. Okay. This example here, it says, let the graph of G be a translation 4 units left, followed by a horizontal shrink by a factor of 1/3 of the graph x squared plus x. Oof, yuck. Again, we're given something in standard form. Do you see how you can't see your transformations there? When I see an x squared term separate from an x term, I know that it's in standard form. But that's okay. Let's go ahead and do the transformations. The first one I see is a translation 4 left. And then I see a horizontal shrink. Oops, let me do this in red. I see a horizontal shrink by a factor of 1/3. Okay, and we want to write a rule for G. So 4 units to the left, the function notation is f of x plus 4 for that. Again, I knew to put it in parentheses because it was horizontal. What this function notation means is to replace x with x plus 4. Okay, so everywhere I see an x, I'm going to replace with x plus 4. And then I have plus, and again I see x, so I'm going to replace it with x plus 4. Okay, because it's already in standard form, let's go ahead and multiply it out and simplify. I'll have to FOIL the x plus 4 squared. And then don't forget this x plus 4. First times first is x squared. Outer times outer is 4x. Inner times inner is 4x. And last times last is 16. Don't forget this x plus 4. Combine like terms. You have 4x, 4x, and x. So that would be what? 9x. And then 16 and 4 ends up giving me 20. Okay, so that's just the first transformation. And then don't forget we've got the second one, this horizontal shrink by a factor of 1/3. Those are weird, okay? The key word for horizontal stretch or shrink is reciprocal. So instead of using 1/3, I'm going to be doing f of 3x, which remember f of 3x means to replace x with 3x. So for step number 2, everywhere I saw an x, I'm going to replace it with 3x. Okay, so I'm going to replace this x right here first with 3x. Then we have plus 9. Again, I have another x that I'm going to replace with 3x. And then plus 20. Okay, let's simplify this. Because there's multiplication here, I can square each part. 3 squared is 9, x squared is x squared. Okay, remember squaring something means to multiply it by itself. So another way to look at that is to just think of it as 3x times 3x, which also gives you 9x squared. Okay, then we have plus 27x plus 20. I wanted us to write a rule for G, so I'm going to name it G. G of x equals 9x squared plus 27x plus 20. Okay, this is in standard form, not vertex form. So for part B where it says, can you easily identify the vertex? I would say, no, the vertex can't be determined at this time. Can't be determined at this time. Again, we've got to wait for lesson 5, and in the next lesson we'll go over how to do that. If you think that these examples are just way too easy for you, give example 5 and the student practice a try. These are real world examples where you can actually see transformations happening in real life.